Hello, we are covering 7.2 Law of Cosines. So take notes and hopefully you are keeping up with the homework. Okay, so Law of Cosines. So we looked at Law of Sines last time. And here we have Law of Cosines. Okay, so again, we use these to solve non-right triangles, which are called oblique triangles. So here, so oblique. And we use law of cosines if we are given one of the following. So here, we might have a side angle side. So that looks like this. If you have a triangle, you might be given a side and then the included angle between the two sides. Okay, so that's side angle side. Side, side, side. Okay, so so you might have this situation here, side, side, side. Okay, or you might have side, side, angle, side, side angle, and so side, side angle means you have side, side, and then an angle. Okay, in that order. So we could have gone, instead of going this direction, side, side, and then an angle, the first angle you get to, you could go the other direction too. You could go side, side, and then this angle. Okay. But in any case, you have this side, side angle. Now this third case here. So note, when you do have the side, side angle case, it is possible, it's possible to have no triangle. Oops. It's possible to have no triangle. It's possible to have one triangle. And it's also actually possible to have two triangles. Okay. This case, we call this the ambiguous case. So this one, the side-side angle will be covered in the next section. Okay. So covered in 7.3. Okay, so we won't do this example here in this video. We will do these two. Okay. All right. So so what do we use? What is the law of cosines? What does it say? So this is what you would use to solve. So they, again, it's just like law of sines, they have the formula written 6 different ways, and they have the first 3. It's written so that you solve for one of the sides, and then the other 3 are written so that you are solving for one of the angles. Since we have 3 sides and 3 angles, that gives us 6 different formulas. Okay, so you don't have to memorize all 6. To me, if you just memorize this structure, then you can just manipulate it to however you want. So instead of using A, B, and C for angle A, angle B, angle C, I'm going to use X, Y, Z. Okay, and I'm going to use these funny looking X, Y's, and Z's. So I'm going to use this X, Y, and Z. Okay, and I'm going to use these to represent the 3 angles. So any of the 3 angles, and then I'll just use the little X, Y, and Z to represent the 3 sides. Okay, doesn't matter which angle or side we're talking about. Okay, the only thing that matters is this formula. So the formula is x squared equals y squared plus z squared. So you can almost remember this part because it's like the Pythagorean theorem, right? And then minus, it's always going to be minus 2. It's always going to be minus 2 times. And the thing that goes here is always going to be these 2. So whether you have side A here, if this is side A, this is B and C. If this is side B, then this is A and C. If this is C, then this is A and B, right? These three are all three different, okay? But whatever you put here and here, that's what goes here. It's going to be 2 times Y times Z, okay? So if this is A, B, C, side A, side B, side C, then this will be B and C, okay? These two have to match these two, okay? And then you do the cosine, and the angle that goes here has to be the angle that matches here, okay? So if this is A, then if this is A, you end with A. If this is B, you end with B. If this is C, you end with C, okay? So I'm just going to put this here, okay? So really, it's one formula, not 6, okay? If you want to memorize all 6, that's up to you, okay? All right, so let's take a look at an example here, and that way you can see what I mean, how about manipulating that one formula regardless of what you're given. Okay, so, and we'll do side angle side, okay? All right, so suppose you have to solve triangle ABC. So solve triangle ABC if A is 60 degrees, B equals 25, and C equals 32. Okay, so suppose we have that. Again, I still like to draw my triangles, okay, and label them. And A is 60, B is 25, little c is 32, okay? And since I'm solving, I like to list all 6 parts. It kind of keeps everything organized. Okay, so I have this here, and I know that A is 60. What else do I have? Little b is 25. Little c is 32. Okay, so I have to solve for these 3 here. Okay, so I have capital A and little b and little c. So to me, that tells me that I can use, I'm going to take that formula, and since I have angle A 60 degrees, I'm going to use that here. So if that's angle A, then this starts with little a. Okay, so I'm going to, here, let me pull up the formula there. All right, so I'm going to start with little a, okay? And I'm going to use this formula, a squared equals, so then the other 2 must be here. And if those 2 are b and c, then these 2 here will be b and c, and it's cosine a, okay? So this is what I'm using to solve for little a. So little a is going to be 25 squared plus 32 squared minus 2 times 25 times 32 times the cosine of 60. Okay? All right, so punch that all into your calculator. Make sure you're in the correct mode. And you should get a squared equals 849. And then take the square root. So square root of 849. You get roughly 29.14. Okay, so here we're dealing with 2 significant digits, so this will round to 29. Okay, so 29. Okay, so again, you take the formula. Let me go back up here. You take this formula and you just manipulate it so that it fits what you're trying to solve for. Okay, so if you're given B and C, right, an angle A, that's angle A. Well, that's the only thing you can put here, right? You don't have choices for the angles. So that's kind of a giveaway. If you can only put angle A here, then this is going to be little a. Okay. All right. Okay, so that's little a. We have all of these here. And now, now I can use, now that I have little a in And angle A, I can actually use law of sines now to solve for the others instead of using law of cosines. To me, law of sines is just, there's less stuff to plug into, so there's less room for error. Okay, so I would use law of sines once you're able to. Okay, all right, so since I'm going to solve for angle B, let me go ahead, oops, angle B here, okay, and angle B, so I'm going to be using this, oops, okay, so where is it? Sine B over 25, sine B over 25 equals, and we have this one here, so sine 60 over 29, sine 60 over 29, okay? So I'm going to solve for B. Sine B equals 25 times the sine of 60 over 29. And B equals sine inverse of 25 times sine 60 over 29. And when you punch that in, you should get 48.29. So roughly 48.29. Two significant digits, so we're going to go with 48. 48 degrees. 48 degrees in purple. Okay. And then you can do the same thing here for angle. Oh, actually, angle C, we can do 180 minus 60 minus 48. So let's do that over here. For C, we can do 180 minus minus 60 minus 48. So C equals 72. Okay. C equals 72. And there we have solved the triangle. Okay, let's do the second case, side, side, side. Okay, that way you can see how we use that same formula regardless of what we are given. Okay, all right, so case 2, side, side, side. Okay, solve the triangle. Solve triangle ABC. Solve triangle ABC if little a is 34 centimeters, little b is 20 centimeters, and c is 18 centimeters. Okay. All right. So I like to draw my triangle. Okay. Label it A, B, C. Little a is 34. Little b is 20. Little c is 18. Okay. So A, B, C. We actually don't know any of those. A, B, and C. Okay. All right. So I am going to, since we don't know any of these, I'm just going to go with angle A. Doesn't matter where you start. So if I'm going with angle A, then I'm ending with cosine A, right? Which means that if you're ending with A, then you have to start with A. Okay. And again, then the rest of the formula is going to be this. Okay. So this is what you will be using to solve for A, angle A. All right. All right. So A is 34. So 34 squared equals 20 squared plus 18 squared minus 2 times 20 times 18 times the cosine of A, which is unknown. Okay. All right. So when you when you work this all out, you should get 1156. 1156 equals 724 minus 720 cosine A. Okay, that's 720. Okay, and then here you'll end up with 432 equals negative 720 cosine A. Divide both sides by negative 720. And you get cosine A. So here we have to take the inverse. So if we do cosine inverse of 432 over negative 720, that will give us A. And so A is equal to 126.87 degrees. Okay, roughly. Okay, so this is 120. If we take this to nearest degree, this would be 127 degrees. Okay, so let's go ahead and write that here for A. So A is 127 degrees. Okay, and now I can do, since I have both my A's and a B, I can use law of sines to get angle B. All right, so angle B, I can do sine B. Sine B over 20 equals sine of 127 over 34. Okay, and then here, so B, solving for B, B equals sine inverse of 20 times sine 127 all over 34. Okay, and if you punch that into your calculator, you get approximately 28.02 degrees. So we're going to go with 28 degrees for angle B. 28 degrees. And now that I have these two, angle C, I can do 180 minus, right? So angle C, I can do 180 minus 127 minus 28. So angle C equals 25 degrees. Okay, so that's how you would do this using law of cosines. And like I said, once you use law of cosines, then you're able to use law of sines afterwards. All right, if you have any questions, make sure you text me, make sure you email me. I will see you. That's only one video, part one. There's no part two. Okay. Don't forget to check in for attendance.